Hello everyone, welcome you back for the further discussions on the actuators. Now here the actuators are classified into three types depending upon the type of the application. The first one is nothing but the linear actuator, the second one is nothing but the rotary actuator, the third one is the actuators to operate the flow control valve. Now here the actuators are used for the what we can say the linear motion itself. Most of the actuators what we are using, either it may be a hydraulic or it may be a pneumatic, depending upon the type of the application, how the pressures what it is required, and also how the actuation it has to be done. It is also classified depending upon the type. The first one is nothing but a linear actuator, the second one is nothing but the rotary actuator, and the third one is nothing but the actuators to operate the flow control valve. The third one is nothing but these are used to control the flow and as well as the pressure of the fluid, such as the gases, or it may be the steam, or it may be the liquids. The first what we are discussing is nothing but the linear actuators, or indirectly what we can say the linear cylinders. The construction of the hydraulic and as well as the pneumatic of the linear actuators are both are similar type, but however the operation and also the operating pressures are little different. Why means, especially in the case of the hydraulic cylinders, or it may be the hydraulic actuated linear cylinders, there if there is no 100% tolerance also, it is very easy to operate, because the viscosity of the hydraulic oils what we are using is little more. But in the case of the pneumatic linear actuators, if the tolerances is of less, automatically there is a chances of leakages. If the leakages is there, means the required pressures it cannot be generated. For that reason, the typical pressures of the hydraulic cylinders, that it will be somewhere around 100 bars, but the actuations what can be obtained by using the pneumatic systems is only the 10 bars. Now the next classification is nothing but the single acting cylinders. The single acting cylinders produces the work in only one direction and the motion, hence they are named as the single acting cylinders. The single acting cylinders is of two types, either it is moved by means of the return stroke, is moved by means of the gravity, or by means of the spring. Now here the schematic diagram shows the spring loaded single acting cylinder. The compressed air pushes the piston located in the cylinder barrel, causing the desired motion. The return stroke takes place by the action of the spring. Generally, the spring is provided at the rod end of the cylinder only. The main components of the what we can say the single acting cylinders are the piston, the U-cup seal, the cylinder body, o-ring and end cover, the bushes, the piston rod, the spring and the piston. See, these are the components normally what we are using in the case of the pneumatic cylinders. Especially in the case of the pneumatic cylinders, the sealants and also the sealing materials, the requirement it should be a maximum, because as we know that the viscosity of the air is lesser and there is a chances of leakages. Once if the leakages is there, automatically the pressure development or the pressure developing in the application end is lesser. The next part what we are discussing is nothing but the double acting cylinder. The main parts of the hydraulic double acting cylinder consists of the piston rod, cylinder tube and a end cap. Now first we will go to the sketch, and then afterwards we'll go back to the explanation part. Now the sketch shows the double acting cylinder. The double acting cylinder consists of the two openings. The one is the extended port, the another one is the retracted port, or the inlet port, and as well as the what we can say the retracted port. Now here the movement of the piston is taking place from the left to right with respect to the sketch. Once if the piston has to travel from the left to right, the air or the pneumatic which is under high pressure, it should be applied through the extended port, and then the piston will start moving from the piston end to the rod end. Then in the retraction portion, the retraction or the reverse stroke, if it has to be means the air it has to be passed from the retracted port or the outlet port. Now here both the ports it should be connected to the hydraulic or it may be a pneumatic system. But here as we are dealing with respect to the pneumatic cylinders, both the ports it should be connected to the pneumatic systems. These it should be operated at high pressures. If the continuous movement it has to be achieved, if you want to achieve a continuous movement, the extended port and as well as retracted port it should operate continuously. In that case only the to and fro motion of the piston can be achieved. The piston divides the cylinder into a two chamber, namely the rod end cylinder. The another one is nothing but a piston end cylinder. Normally the piston end cylinder or the piston end side is also called as the blank end side. The seal prevents the leakages of the air between these two chambers. The cylinder tube is fitted within end caps. The pressurized oil or the air entering into the cylinder chamber through the port provided, and the rod end covers the plate, and the wiper seal provides to prevent the leakages of the oil and the entry of the contaminant into the cylinder. Now here the contamination of the wiper seal bearing and as well as the sealing ring is called as the cartridge assembly. This cartridge assembly it will be at the rod end. The cylinder end cushioning. Any cylinder, either it may be a single acting cylinder or it may be a double acting cylinder, a cushioning should be there. If the cushioning is there, means the landing of the what we can say the piston, it will be in a smoother one. Especially in the case of the deceleration or in the return stroke, the piston starts when the trapped plunger enters the opening in the cap and closes the main fluid exits. As the piston starts descending it, what will happen? There is a chance of impacting to the cylinder head. That impacting to the cylinder head is minimized by using a cushion at the end of the cylinder. During the last portion of the stroke, the oil has to exhaust through an adjustable opening since the main fluid exhaust closes. Thus, the remaining fluid exists through the cushioning wall. The amount of the cushioning wall can be adjusted by means of the cushioning screw. Now here you can observe that there are two walls will be there. One is nothing but a cushioning adjusting wall. The another one is nothing but what we can say a shuttle wall, or it's nothing but a check wall. These two walls it will be there, where the cushioning it will be a minimizing the impact on the cylinders. Now the next question is, why do we need the cushioning effect, especially in the case of either it may be a single acting cylinder or it may be a double acting cylinder. But in the case of the double acting cylinders, the cushioning it should be at the both the ends. But here in most of the cases, the what we can say the cylinder end cushioning it will be in the single acting only. The double acting cylinders they generally contains the cylinder cushions at the end of the cylinder to slow down the movement of the piston near the end of the stroke. When the pressurized air is supplied at the inlet port of the cylinder, the piston accelerates and the travel inside the cylinder. The piston has to slow down at the end of the stroke to prevent the excessive impact of the end cap. This shock load arises not only from the fluid pressure but also by the kinetic energy and also the load on the system. These end travel shock loads can be reduced by using what we can say the cushioning at the end of the cylinder head. The prevention of the shock due to the stoppage of the load at the end of the piston stroke cushion devices are used. These allows the deceleration characteristics to adjust the different loads. When the cylinder piston is actuated, the fluid enters the cylinder port and flows through a little check valve so that the entire piston area can be utilized to produce a force of motion. See, this is why we need a cushion, especially in the case of either it may be in a single acting or it may be a double acting